Hi everyone, I'm Shihan and I'm from Duke University, and thanks for everyone attending this talk. And today I will talk about how to implement and design the password pre-authentication by content delivery networks. And nowadays, we all know that password login is very prevalent on the internet, and we all use password every day. However, there are a lot of problems with password logins. One of the examples is called the application layer DOS attacks, ADOS attacks. And it means that an attacker will try to exhaust a server's CPUs by sending just a small amount of the traffic. And it's different from DDoS because usually DDoS takes a lot of traffic. But actually, ADOS attacks usually happens in the context of the credential stuffing attacks. In credential stuffing attacks, attackers usually try to repeat many passwords to guess your password and to crack the user accounts. And according to Akamai's report, there are about 280 million suspicious logins per day. So it introduced a heavy load to web servers. So here we show a real-world examples of the ADOS attacks, in which where we successfully bypass existing defense provided by Cloudflare. And in this experience, we set up a four-core web server, and we use Cloudflare as our CDN, and we enable its DOS mechanism, enable its firewall, rate limit, and bot detection mechanism. And we set up an attacker and to control multiple distributed bots, and we control these bots to send a total 150 logins per second and to the Cloudflare. And we find that all of the login requests will bypass Cloudflare and actually reach our web server. Cloudflare does not intercept these requests. And it leads to the CPUs on the server raised to 100%. And also, the server actually cannot serve any other network request. So it means that we successfully launch ADOS attacks target on our server. So there are many existing solutions, but they all have their own limitations. For example, a website may use CAPTCHA to avoid the bot request. However, CAPTCHA actually nowadays can be solved by the AI technology. And we can also use two-factor authentication, but actually 2FA should use the password as the first factor, so it does not avoid the DOS attack. And we may also use rate limit, but as we show in our experience, actually, we can use VPN to bypass the rate limit by switching the IP address. And nowadays, CDNs may also provide some bot detection mechanism, but these mechanisms are usually based on machine learning and behavior analysis, so they cannot avoid the false negative or false positive. And finally, some websites may also use a single sign-on. For example, you can use your Google account to log in into other websites. But the single sign-on may lead to single point of failure. It means that if your account of an SSO provider is compromised, then all associated websites are at a risk. So therefore, in this work, we present the PreAcher, which provides the DOS prevention, and it preserves the password secrecy, and it also maintains good usability. The key insight of PreAcher is that we design and deploy the pre-authentication on a CDN without exposing the password to the CDN. And in this case, the CDN can help the web server to filter out the embedded login without those without correct password. As this figure shows, if an attacker sends the login request with wrong password, then it will be intercepted by the CDN and it will not reach the web server. However, this is a very simple idea. It comes with two problems. The first one is that the attacker inside CDNs may impersonate the user. And the second one is that it's offline dictionary attacks by attacker inside the CDN. For the first one, it means that a malicious CDN insider can help the attacker to cheat the web server, even the attacker doesn't know about the password. And for the second one, it means that the CDN can collect the historical passwords or leaked passwords from internet, and it can process these password data set and to generate a password dictionary This password dictionary may only include a small number of the passwords, but they are very likely to be the correct password. And the CDN can just try one by one by running its own pre-authentication system to know that which one is the correct one. And finally, they can know the correct password. So our solution to avoid the first problem that attacker inside CDN may impersonate a user is to involve the server to double check the authentication. It means that we set up pre-authentication on a CDN, and we will also have a full authentication on the server. Specifically, when the CDN tries to cheat the web server, then the web server will find that the request actually does not include the right password, and it will fail on the first authentication, so it will still reject the login request. And our solution to solve the offline dictionary attacks by CDN is to use a technique called the locality-sensitive hashing. We have an observation that passwords in a dictionary usually share some similarity, as this figure shows. And we come up with an idea that we can group a similar password into one pseudo password for pre-authentication. So that's why we use the locality-sensitive hashing, LSH. And therefore, when a CDN tries password in the dictionary, you will find that so many candidates can pass the pre-authentication, and it has to query the server to know which one is the real one. But what if the CDN tries many online queries to the server to identify the correct password in the dictionary? So actually, this can be detected because we can detect such an attack when the server receives more than Q-fed full authentication queries. And for example, the CDN may send many password candidates to the server. It says that these passwords all pass the pre-authentication. But actually, the web server may find that so many passwords, they failed on the full authentication, but CDN claim that they passed the pre-authentication. So it means that something bad happens, so that we can detect such an attack. Finally, let's put everything together. When a user tries to log in, the client will first hash the password with the LSH to a pseudo password for pre-authentication. It's the P prime shown in this figure. And then it will also encrypt the password to a message, have an encrypted password for full authentication. Then the client will send this message to the CDN. It will also conduct the pre-authentication with the CDN to finish the pre-authentication. And when the pre-authentication succeeds, then the CDN will forward the message to the web server. Then the web server will decrypt the password and to have the real password, and use this password to run the full authentication. And our implementation in the design of the PreAcher actually make it easy to deploy. For the server operations, we implemented as a C++ library, and it can implement it and deploy it by web developers. And for client operations, we implemented as a JavaScript library, and it can be imported by web developers into web pages. And most importantly, for CDN operation, it seems that we need the cooperation from CDNs, but in PreAcher, we use serverless computing service that is already provided by CDNs too, and the web developer can deploy its own customized JavaScript code snip on CDN edge server to implement our CDN operation. So even for the CDN operation, they can be deployed by the web developers. So our final result is that our design makes the PreAcher can be unilaterally deployed by web developers and to protect their websites. Finally, to evaluate PreAcher, we set up two experiments. One is the testbed experiment. Another one is the internet experience. And on our testbed, we use Azure VMs as the client server in CDN. And on the internet experience, we use Azure VM as the client server, but we can use Cloudflare as the CDN. And we also compare our solution with two strawman solutions. One is baseline, which in which that a CDN simply forward every login request to a server. This is the current practice. And And another solution is called SGX CDN. It means that we use SGX on CDN to fully authenticate the user to filter out those invalidated logins. In our evaluation of the ADOS attacks, we first send user traffic with 100 invalid logins per second to our server and also through the CDN machine. And we measure throughput of valid logins. And we can find that without attack and all of the methods they can serve the user traffic that close to 100 logins per second. However, once we have attackers who is sending 400 invalid logins per second, both baseline and SGX CDNs cannot serve any valid user logins. But PreAcher can still maintain a high throughput that close to 100 logins per second on the testbed and on the internet. We also evaluate our LS efficacy. We simulate an attacker inside the CDN to crack 5,000 user accounts. And we use algorithms pass and a dataset 4IQ to generate a password dictionary for each user. And we compute the cracking rate of user accounts when PreAcher is deployed. And here, actually, the cracking rate is determined by two parameters. One is the K. The K is the parameter in our LSH algorithms. It's called weighted K-mer mean hash. And another parameter Q is as we mentioned before, it's the failure number after which the server will report an offline dictionary attack. So this figure shows the cracking rate of the user accounts, and we can find that with larger K and larger Q, the cracking account will be larger. And actually, the K value here is a trade-off between ADOS defense and ODA prevention. It's because that actually the percentage of the invalid logins that can pass pre-authentication is 1 over C2K. So with larger K, then this percentage will become smaller. Then the ADOS defense ability will be stronger. So we needed to select the proper K and Q values. And we can find that according to this figure, if we set K as 4 and Q as 20, we can have a cracking rate less than 0.2%, and also we have a very low, those 1 over C2K. Finally, for conclusion, we propose the PreAcher. It will securely pre-authenticate the users on CDNs, and it helps to filter out malicious logins requests without correct passwords, and the CDNs cannot access or guess the user password. And PreAcher is immediately deployable on internet by web servers unilaterally, because we implement the client operation by JavaScript and we use serverless computing for CDN operation. And our code is released on GitHub. And thanks for everyone attending this talk. I'm happy to take any question. Thank you.